Good afternoon, ladies and gentlemen. So first, I have to apologize. I changed the topic just yesterday because some communication issues. So that's why it is different from audience list. But I promise it will be also very interesting topic you would like. So just by following HS, my colleagues in Korea. So actually, in Momentive, we also have very advanced technology to show the different silicon rubber technology. What I want to present today is UV cure silicon rubber. So first is that I just quickly go through the silicon rubber because I know most of you are very familiar with silicon rubbers, as just HS asked. So usually when we look at a silicon elastomer family, we can divide it in two kinds of status. First is a high consistent rubber, or we call high temperature cured rubber, or something like a high consistency elastomer. It's like a solid rubber. If you feel the high consistent rubber, you will feel it's like a kid's plasticine, just like a clay. So you can, it has very how to say, high viscosity, or we call plasticity. So, but in silicon industry, we all call HCR or HCE. So because in the following slides, I will use the abbreviation for like HCR for high consistent rubber, and also LSR for liquid silicon rubber. So another one is the liquid silicon rubber. It is like a high viscosity slurry. The viscosity is usually between 200 pascal second to 500 pascal second, depends on different grades. And both of these rubber are, how to say, it's we call, for us, because we are material supplier, so we call finished good. But for customer, both of them need a processing step, like compression molding or injection molding, to make the silicon rubber material to be real rubber parts. So for the curing, or we call processing, for HCR, usually we will have the peroxide and platinum catalyst. For peroxide, we call radical group reaction. For platinum, we call addition cured. So for liquid silicon rubber, it's a kind of ready-to-use material because we put platinum catalyst in A part and cross-linker in B part. The customer just use the injection molding machine to mix it together and inject to the mold, and can be used for the rubber part. But both of them, no matter HCR or LSR, it requires high temperature, more than 120 degrees at least. So in that way, just if we look at current industry requirement, you will find a lot of applications like high-end consumer wearable device, medical parts, like something like a mask, because a lot of area requires silicon rubber to combine with plastic or other thing like electronic device. But if we use or apply the high temperature, it will destroy the plastic or destroy the electronic device. That's why how to make silicon rubber can be cured or processed in a relatively low temperature will be very interested to the industrial area. So that's why we developed the UV cured elastomer, silicon elastomer product. We have both the UV cured HCR and also LSR. So I would present later. So in that way, we can cure the material less than 70 degree, and also for LSR, UV cured LSR also can be injected into the injection molding machine less than 70 degree. And no matter the UV cured material or we call regular elastomer material. So in the processing facility, usually for the HCR, we have the compression molding, like the molding machine and also extrusion machine for the tubing, like a medical tube, and also calendarings for the silicone rubber film. But for the LSR, always have the high precise injection molding machine. Okay, so why we need the UV cured LSR? Actually, there are 4 advantages of UV technology. First is very fast, because if we use the heat to cure the regular silicone rubber, for peroxide cured material, it takes maybe more than 3 to 10 minutes, very long. For LSR, at least 1 or 2 minutes. And for UV LSR or UV HCR, only a few seconds to few minutes, depends on the dimensions. So it's very fast. And in that way, you can have very short processing loading time. And also, it is a very clean process, because as you know, in the high temperature, the silicone rubber sometimes will release or emit the volatile, low volatile. But for UV cured, we don't have such kind of issues. And especially for like, for example, I will introduce the UV cured HCR for extrusion, like for medical tube. Usually in the traditional way, they will use the peroxide to be the catalyst and use the extruder to make the tube. But in that way, the peroxide will be decomposed a lot of different low volatile to generate a smell, to generate some harmful low-end molecules, which are not good for medical tube. But for UV catalyst silicone elastomer, this issue can be solved. And also it's green technology, because if we use the regular heat to be the medium for the curing, it costs a lot of energy, because you need electricity to make the heat very high temperature, right? But for the UV cured elastomer, you just need a UV light, and you don't need too much electricity to be the power. Also, it is very new technology, as I mentioned. In that way, I can cure the silicone rubber in a really low temperature. It can be applied for like bond with silicone rubber, with PP, PE, some new plastic with very low temperature melting point. And at that moment, we also can use UV cured LSR to make a 3-dimension printing model. There is a curve to show the different system for silicone rubber to be cross-linked, the time. So we can see the first one is the peroxide HCR. It's tested at 150 degrees, and we can see if it reaches 90% cured, it almost like 5 minutes or more than 5 minutes. For regular LSR, liquid silicone rubber, platinum catalyst, the ready-to-use LSR, it's less than 1 minute, but still need some time. But for UV LSR, it's very fast. When you turn on the UV light, the cross-link just started. So very quick, few seconds, it can be done. Okay, so as I mentioned, so the name is UV cured silicone rubber. So UV light is very important, very, very important. Not every light, or not all, as we know, we have different UVA, UVB, UVC, and each one contains different wavelengths. So that's why we need to choose a right UV light for our UV cured silicone elastomer. That's why UV lamp system is very critical. So when we try to choose the UV light, there are some standard for you to choose that one. So we listed something here. Here is this is the first one is we call electrode system, and we also have LED and microwave system. So if you want to make or choose our UV cured silicone rubber, you should to think about which part do you want to make. If you make a bigger part by like extrusion or molding, it's better to choose electrode system because the cost or investment is lower. So it's very good for big part. But for very precise small part or like very, how to say, complicated geography, so it's better to use the LED because LED spectrum is UV spectrum is much more narrow. At the same time, we also need to think about the UV light cannot contain too much IR light because sometimes when the customer choose UV light, if they choose some UV light is made from just a regular UV manufacturer, it contains IR inside. But IR will generate the heat. So in that way, the heat will destroy the transparent mode. That's why we need to remove the IR spectrum from UV spectrum. So this is a very simple legend for the how UV silicone rubber, actually for liquid silicone rubber, work. Because we still use the traditional LSR injection molding machine. The only difference is first is material system. Because as most people here, if you touch the LSR or get familiar with LSR, you know in traditional LSR injection molding machine we have A, B part, right? So A part contains catalyst, B part contains cross-link. So you use a pump to pump both part into the static mixer, get them to be very even system and go into the mold, right? But for UV LSR, you don't need to put the A part into the A part drum. We only have B part as a base. And we have A part, we call catalyst, but the catalyst only 2% with the B part. So you only need to put the A part into the dosing system in the injection molding machine. So if you are running the UV LSR system, you will see there is no A part, only B part in the machine. The A part is in dosing system. Then that go to the static mixer to get mixing. And for the mold, they're also different because the mold, if you need the material cured in the cavity, you need the transparent mold. Usually we recommend PMMA or polycarbonate mold to be the transparent mold for the curing. Otherwise, the light will be stopped. So it's not good for the curing. That's the difference between the UV LSR and the traditional LSR. And of course, from Momentive, if you want to get UV LSR material, we have a pail kit and a drum kit. For pail kit, usually 15 kg B as the base material with 2% A catalyst. For the drum kit, we have 200 kg drum as the base material and with 2% catalyst. And also, because the UV light is very fast, light is very fast than other medium, so the curing time is very fast as well. Usually, we only need a second to few minutes. You can make a big part. There is a typical performance or properties of our UV LSR product. At that moment, we have 4 grades for different applications. First two, UV Electro 235-2 and 225-1 are mainly focusing on the high voltage insulator market. And the other two, UV LSR 2030 and the UV LSR 2060, are focused on the medical and the consumer market. So you can choose the material depends on the viscosity and the hardness and also your application. So this is a the application for the UV LSR used for we call two-component overmolding process, because most people know that there are a lot of how to say them, two-component or multiple component material are developed for the advanced technology applications, like we have a lot of silicon rubber bonding with metal, bonding with plastic, and of course we can use self-bonding material. But for some material, like here are two cases. One is that for red wine, and the plastic is the PP. The PP melting point is very low. You cannot use the traditional silicon rubber to get bonded with this plastic, because if you apply heat, the plastic will be destroyed. And here is something we call used for soap case. So soap case, the plastic is also PP and also can be used PE, and the same issue happens. So that's why we use the silicon rubber, just use the UV cured silicon rubber to bond with low temperature, low melting temperature plastic to make the part. So that's why if we look at the comparison, we can see like a traditional LSR 2K. 2K means two component injection overmolding requires more than 120 degrees. And it is like a limitation to silicon and plastic combination, especially for like I mentioned, PP, polyester. And for low temperature UV cured process, we can only run the overmolding about 30 to 40 degrees. It's in room temperature. So it's very good for us to combine the silicon rubber to PE, PP, and other plastics who has a very, very low melting point. And at the same time, even the temperature is lower, as I mentioned before, the curing speed is still very fast. That's why we can make even bigger or complex part. Okay, so after that, I would also introduce the UV cured HCR, the high consistent rubber for extrusion tubing process. Because the traditional way to make the medical tube or wire or cable, we just use the traditional extruder. There is almost like more than 450 degrees, very high temperature at the extruder die, and the material will go through the extruder and get the shape like the tube shape, and go through the heating tunnel to make the final product. Then we make the curl to get the wire or cable or like a medical tube. And sometimes we need the post-cure or post-bake if it's applied for medical application. So it requires, you can see it requires really high energy, because all the temperature are very high. And at the same time, you will also, if someone runs the extruder, will see the most difficult thing is the bubble in the silicon rubber, because high temperature. First is if the silicon rubber contains some moisture, then moisture will become the vapor to generate the bubble. Second is if it's cured by the addition cure system, it contains cross-linker. Cross-linker will decompose some low volatile and to generate the bubble. But okay, so if we use UV technology, the same way, but the HCR just goes through the extruder and exposed at the UV light. It can be cured in room temperature and very fast. So there is first is a very, very low energy consumption. Second is no bubble can be found. So that's why if you use the UV cured HCR for extruding, it can save a lot of productivity and improve the whole process very much. We also have 3 different grades for the UV cured HCl for tubing and extruding. So we have 50, 60, 70, this short A hardness. So you can use, usually 50 and 60 are mainly focusing on the medical tube, and 70 are used for cable because of the high hardness and very, very stiff strength. Okay, so for all kinds of material I mentioned, I always mention that for medical application or consumer application, actually we got a lot of, or passed a lot of medical certificate. For example, like our material, Adicil UV60EX, it's UV cured HCl for tubing, and UV LSL 2030, UV LSL 2060, it's passed the ISO 10993 and also USP Class 6. And also it's the extraction limit according to 21 CF 177 to 2600. And also the Adicil UV60EX also passed European Pharmacopoeia 3.1.9. So, and all UV curing grades are also compliant with BFR and FDA. So that means no worry to use this material for food content, drug content, medical applications. And also very interesting thing is because now if you apply some regular or traditional heat-cured silicone rubber, a lot of people will mix the pigment or color paste into the material to make it shining, fancy. But how about the UV cured? Actually, we can do that way. But remember, the color we can first from Momentive we provide the UV cured elastomer color paste. But all kinds of color paste has one properties, just can make the light through. Otherwise, it cannot be cured. So that's why even like you look at the dark one here, it's like how to say, semi-transparent black, and there is no totally white or totally black one at that moment. Otherwise, the light will be blocked by the color. So if it's blocked, you can think about the material can be only cured at the surface, cannot make the light go inside to make the cross link inside. So that's why we can make the color, but we still need to be very cautious about how to choose the color. And there is some applications. As mentioned, we have 2-component molding I mentioned, and we also have the extrusion as this one. It's like LED stripping. You can put the light dot inside, and because all kinds of light dot contains electronic device. So if we use traditional heat cured or processing way, the heat will destroy the electronic things. And also this is a big part for high voltage insulator, because usually, as someone might know, if we make the HVI part, sometimes the length can be 4 to 5 meters long, and the diameter will be almost like ½ meters as a diameter, or even huge. So traditional way is not to use the injection molding machine. They will mix the A and B part, like a 2-drum part, and go into a big mold. There is steam surrounding the mold. So the curing time will be long time, can be 1 day, 24 hours to make the part. But for example, if we can use UV cured technology, we mix A and B, the catalyst and the base, and make it into the mold. Just to use the light to catalyst the material. Then it just require maybe few hours can be done for the big part. That's why it's also very, very good material for high productivity. And this is also I mentioned, it's actually made in Europe by one company. So this is a typical applications, but not just limited in those areas. As I mentioned, there are many many areas we need to think about and we can work on. So especially, and most of you are very interested in 3D print. Actually, this material is a very good candidate for 3D print. Yeah, this is one real case that we work with this company, Luxo. They are making the LED strip. So they use our UV LSR to make different silicone band or silicone strip to contain the light or LED inside, so that it is more safe for the electronic device. Okay, this is my last page, and thank you everybody. And I'm based in Shanghai, so if anyone of all the audience, you have any question, just can reach me out by cell phone, by mail. And if you are interested in Momentive material, you can also send me a request. I can provide a sample or data sheet for you. Thank you.